Bonjour à tous. Et merci d'être ici pour cette conférence. Donc en principe, vous devriez être les S9 du Master DRAC et les S7 de tous les domaines d'études. C'est une conférence ouverte à tous, donc on a quelques enseignants aussi qui sont là et puis quelques extérieurs éventuellement. Donc cette conférence va vous être donnée par Dr Lia Marchi, qui est enseignante-chercheur à l'Université de Bologne en Italie, qui est ici à Rouen pour une petite semaine dans le cadre d'un échange Erasmus enseignant et qui nous fait le grand honneur d'avoir choisi Rouen pour cette semaine d'échange ou de voyage. Et donc voilà, on a commencé à travailler avec elle sur les différents sujets de recherche qu'on pourrait avoir en commun. Et donc aujourd'hui, la conférence qu'elle vous propose, qui s'intitule Sustainability and Resilience Design Support Tools for Renovation, elle sera en anglais, puisque Lia parle parfaitement l'italien, mais pas trop le français, et donc elle préfère vous parler en anglais. Ce sont des outils d'aide à la conception pour la rénovation résiliente ou la rénovation écologique, on pourrait dire aussi, sachant que le terme sustainability, je ne suis pas sûr qu'on puisse le traduire facilement en français par soutenable. Hein, c'est peut-être pas tout à fait ça que l'IA a en tête quand elle parle de sustainability. Mais je lui laisserai développer le propos et puis se présenter aussi un peu mieux que ce que je n'ai fait. Je vous laisse la parole.
Sur la conception des usines durables, donc à la fournie une boîte à outils pour atténuer un futur l'impact sur le paysage. Du coup, c'est en lien direct avec le site du projet et le sujet en S7 ou en S9. Elle est publiée en anglais. C'est téléchargeable. Non, il faut qu'on achète le livre pour l'école.
Oh no, I will bring one for you. So, thank you very much for the presentation and also for welcoming me so warmly here in Rouen. Just some more words about me, because I can't understand French, so I just grasp some words, but I don't know actually what has been already said about me. I'm a PhD. I'm an architect before PhD. Architect, PhD in technology for architecture. And I'm currently a postdoctoral research fellow at the University of Bologna, still Department of Architecture, where I also have a course on design project, detailed design within a specific international course on historic building rehabilitation. And so it's, I'm a sort of, let's say, assistant professor, the equivalent of the assistant professor in France. So again, thanks for coming. And as it has already been introduced, I'm talking about a topic that it's particularly interesting for me. I've been focusing on this topic, I would say, for 5 and more years up to now, which is sustainability and resilience rating system to support the design and the designers of the built environment in providing more sustainable and more resilient projects, more resilient buildings. And so today I'm focusing in particular on renovation projects, but this kind of tools that I'm presenting are also very good at supporting designers in new construction, new project on new buildings. This is the structure of this presentation. Can you hear me well? Okay. This is a structure. So firstly, I'm going to introduce you briefly the background around sustainable retrofitting. Why should we talk about retrofitting in a sustainable way? So basically, I'm introducing the topic of energy transition and giving you some insight on the role that architects play in reshaping the built environment in a sustainable and resilient way. Then, since the topic is quite complex and we could really benefit from, let's say, design support tool that could help us in providing very good project, some design support tools have been developed to assist architects, engineers, and the other stakeholders of the built environment to, let's say, analyze the project according to different evaluation categories from different aspects of the built environment, and then in striking a balance, finding the best compromise when you have a project with different aspects to be, let's say, addressed. Then the third section of this presentation will give you an overview, very brief, of some, let's say, design strategies that you can grasp from the application of these sustainability rating tools. And in particular, I'm going to present to you a sustainability rating tool that has been developed in Italy, specifically for the renovation of historic buildings that have an historic value, cultural heritage. And then, as last section, I will conclude, if you are still alive, will some prospect further development of these tools, some, let's say, some trials from my side on the integration of these tools for potential improvement, but also some actual developments of the organization that are providing this tool and offering them on the market. So, sustainable retrofitting. I assume that you all know that we need to push the accelerator on what is called the energy transition and the sustainable development, because it is a really, let's say, actual and urgent need that we have to cope with, a urgent challenge. Just think that at the opening of the 2022 general debate, the United Nations General Secretary Guterres implored, not just said, but implored world leaders to end our suicidal war against nature. And this is not just, let's say, an alert, but it's, and it's not just to scare people. It is a fact based on data which are included in the 2022 IPCC report, sixth report on climate change, that alerts that time to act is now, or it will be too late to cope with the effect of climate change and environmental crisis in more general terms. So it's not just, as I said, a way of for scaring people, but it's something that really we should embed in our way of thinking, of living, and so on. So we should basically adapt ourselves, our lifestyles, our way of producing, of working, and of living also. And as an architect, we pretty much have, let's say, an impact on the way people live. And so we should adapt ourselves for coping with climate change and use less finite resource to cope with the resource depletion. But also we should, let's say, adapt to ensure that the future living environment will be healthier and also more equal, more just for people, not just of today, but also for people of tomorrow. And also we should adapt because we are not now highly dependent, especially in Europe, from energy supply which are not, let's say, managed by us. And the war that we have next door is highly, let's say, highlighting this point. So we also should adapt our way of living and producing and working to recover from socioeconomic crisis that is harshening day by day. just think that in Europe, the rate of energy poverty is dramatically increasing in the last, I would say, 2 or 3 years. So as architect, as I said, we can really make the difference, or not to be too much, let's say, to put a less emphasis on that, we really can have an impact and shape the built environment, which is the object of our work. And the built environment is among the major contributor of the impact of human on the planet, indeed. Just think that globally, more or less 30% of greenhouse emissions are due to the built environment, are related with activities related with the built environment. And at the same time, more or less 40% of final energy consumption globally is related with the built environment activities. This both includes direct and indirect energy production and let's say impact related with energy production. But the, let's say, good news, if it is a news, is that yes, the built environment is among the major contributor of the impact of humans on the planet, but it's also one of the sectors where, let's say, greater reduction potential are estimated. It is estimated, in fact, that in this sector, due to the flexibility of its demand, we can reduce by average of 40% greenhouse gas emissions during operational stages of building by means of retrofitting, as well as 70%, minus 70% of the energy used in new buildings. When you build new buildings, when you design new buildings, new highly efficient buildings, by average, they consume 30% of what would the same building constructed with, let's say, conventional techniques would require. So it is true that constructing new efficient, highly efficient building, it's a good strategy that we can implement. But then the point is that in 50 years, it is estimated that more than 90% of our built environment will be made, will consist of buildings that are already in use today. That means that will consist of buildings not efficient, non-energy efficient. And so the real challenge is not very much to point on new highly efficient, energy efficient building, but rather the greatest reduction potential that we have to face, the greatest challenges is in retrofitting existing buildings. Because, as I said, the turnover of the stock is really small, really slow. We have few buildings, few highly efficient buildings constructed each year compared to instead the amount of buildings that we have already built in the previous decades or even centuries. Generally speaking, the target that we have set in Europe, I would say, it's that for a single family building, we should move from an average of 108 kilowatt per hour per square meter per year of energy consumption of building to at least to less than 15 kilowatt per hour per square meter each year. And to be honest, now the target is even less, because we are pointed at nearly zero energy building and even beyond to positive energy buildings that have, let's say, a surplus of energy instead of requiring energy from the network. And so, basically, despite this recent investment that Europe at least has put in energy efficiency, the International Energy Agency estimated that the expenses in energy retrofitting is still to triple by 2030 to boost energy retrofit rate at about 2.5% per year. Because only in this way, only in this with this path, we could really reach the net zero emission scenarios that we have set globally by 2050. This is just to say some figures, some numbers to say that we really should push on retrofitting of existing buildings rather than, let's say, finding new ways to reduce the energy of buildings, new buildings that already are let's say, very performative. So how to retrofit building? Basically, the main strategy is to implement technical intervention on system and components to upgrade their performance, to retrofit their performances. And for sure, the thermal insulation of envelopes is among the most implemented strategy and even the most, let's say, effective. But then we have also very often windows replacement with new, more, let's say, performing, and also the upgrading of heating system and the integration with renewables. But then this is just, let's say, a set of interventions that are targeted on reducing operational energy, the amount of energy that is required to operate a building, to heating it, to cooling, to lighting, and to heating water, and so on. But the point is that in order to reach very high, let's say, energy efficiency rate in buildings when we retrofit them, indeed we are adding materials that have been processed, that have been, let's say, that have required energy to be being processed. And so the idea is that nowadays it's no longer enough to simply focusing on operational energy, the amount of energy that the building requires, but we also should focus on the overall balance of energy. So both embodied energy in material and in components, and in operational energy itself. Even if operational energy, that is our main focus, is represent the most, let's say, the most important share of the energy required for a building, because the rate is about 90% for the first and 10% for the embodied energy, usually by average. And so the point is that as buildings get more and more energy efficient, it increases also the relative weight of embodied energy, because the operational energy is decreasing and it assumes more relevance, more weight, the other one. And as circularity gained traction in many sectors, also in construction, key players, architects themselves, have been called to perform not just renovation projects, but sustainable renovation projects with, let's say, a long-term perspective, not just focusing on what is consuming now the building, but focusing on the whole life cycle of the building, from the processing of materials to its to the disassemble of the building itself. And this obviously means considering impact from the entire life cycle of added materials and components, rather than only focusing on lowering this operational energy that I mentioned. So as an architect, you can greatly contribute, as I said. For sure, you can significantly influence the early stage of the building life cycle. So choosing materials, choosing, let's say, components, and design buildings that act effectively, that operate effectively. But then another important role that as architect we have is to ensure that information that we, let's say, have on design feature are not lost during the process, during the, let's say, the passage to clients, to owners, to occupants of the building. Otherwise, it's like, let's say, designing a Formula One car and then giving the key to someone who is not able to drive it. So it's useless, basically. And so to ensure information on design features is not lost between designing and commissioning of the building, you can ensure that knowledge is transferred so that the building's circularity and sustainability potential is utilized. This is, let's say, a recommendation of the European Council of Architects, speculating on the European taxonomy for sustainability. And so in this sense, I would say that the Pritzker Prize of the 2021, Anne Lacatone and Jean-Paul Vassal, could have been sort of forerunners in this idea of sustainable retrofitting, because their approach has always been what is mentioned here: never demolish, never remove or replace, always add, transform, and reuse. This is not a project by them, but is rather a sort of adaptive reuse that we have in Bologna, from my university, the city where my university is based. And it's a former greenhouse that has been now transformed into something totally different, but really, let's say, catchy and attractive for people, local people. Here we have, instead of the greenhouse spaces, we have spaces for working, for studying, for cultural events, and also places for, let's say, learn about nature and sustainability. So, still the European Council of Architects, when they talk about the European taxonomy, they point out that the role of architects, it's not related with just the planning and design stage. You can see in the circle that you have different stages of a building life cycle, and you can see how the different impact category, not impact categories, but sustainability goals that the ACE have set contribute differently to the different stages. And so obviously you can see that all of the goals contribute very highly, very much to the planning and design stage. But then you can see that, for example, the climate change mitigation, which is the outer circle, is very, very important during all the other life cycle stages of the building. So to sum up on this point, as architect, we can mitigate climate change by keeping the primary energy demand 10% below NZEB standard as much as possible. We can support circularity by designing buildings that are resource efficient, adaptable, flexible, and dismantleable. We can ensure sustainable use of water by installing water-saving appliances and water collection and so on. And we can adapt our building, prepare our building to adapt to climate change by designing resilient buildings according to the identified climate risk. So as I said, architects play a crucial role to this end, to reduce the impact of the built environment on the planet. And this role is, let's say, performed at several stages, from design to construction and even beyond. So for example, you can implement innovative energy concepts and increase energy efficiency by orientating the building in the best way possible to take advantage of solar heat gains in winter and not in summer. Or also you can design buildings that are compact to minimize heat transfers and so on. You can increase buildings' flexibility and adaptability when performing renovation. So, for example, designing modules and modular spaces that can be changed during the day or during the different seasons. You can just because I had some examples, but yeah, you can also use, let's say, shared space to reduce the amount of new soils that we have to take. We can use also light structures and dry assemblings. You can make efficient use of resources and use low impact materials, as I assume you all well know, and so use only the amount of materials that is necessary. Reusing recycled materials, upcycling instead of downcycling materials, and use obviously bio-based materials and so on. You can choose materials and their quality for increased dismantleability. So using monomaterials is really important because you can recycle them easier in an easier way. But also using dry assembly without glues and foams and so on. Favor water saving appliances and innovative concepts, and also design for resilience by adapting to today's and future climate condition, which means, as in the example that you can see there, that you can, for example, design open spaces in a way that works both in ordinary condition and in the event of flooding. Or you can, let's say, improve the microclimate while improving the health and the well-being of people using that space. This is something that I had yesterday to the presentation because I was in your library and I saw this page from a local newspaper, I would say, that explained very easily and in a very informative way how to reduce the energy, the energy demand of your house. This is just to say that we all are very well aware of what kind of intervention we can implement on the built environment to reduce the impact. But the point is that even if we know specific interventions, so for example, installation of heating pump or installation of solar panels or whatever. And we also, as you can see, can quite easily, let's say, associate this kind of intervention to a specific number, a reduction in the economies, in the bill of the house and also in the energy demand of the house. But despite this, the point is that we very often fail in performing a very effective project because we don't know how to, let's say, consider all the interacting aspects together. And by doing this, by just focusing on specific things time by time, we very usually, let's say, miss some important synergy among the aspects of our building. And we risk to, let's say, fail to benefit from synergies that would benefit the overall balance, the overall quality of the project itself. And this kind of difficulties that we have in approaching a renovation project deals with very different aspects, from environmental implications, where we have to consider both water management, energy efficiency, indoor air quality, and so on. So different aspects that use different indicators also. But also we have to think of social implication of the renovation. For example, especially in buildings that have cultural, let's say, value and historic value, this is a very important part of the, let's say, evaluation process behind design. Then we can have technical difficulties in performing specific intervention. We can have logistic issues. For example, where can the occupants of the building go while the intervention takes place? And also financial constraint. What is the budget of our client? What is, let's say, also the time availability that he or she has to perform the intervention? So this is just to say that, again, we know quite well what intervention we should implement, what action we should do on the built environment, on existing buildings. But the point is that there are so many issues that interact together, and these issues are like oranges and apples are different in nature. So how to evaluate, basically, the weight of energy efficiency along with water efficiency and along with social implication and so on. To help us, I would say, some tools have been developed, and so I'm coming to the second section of the presentation. I don't have the clock, but just to see if I'm going too long. Okay. So, as I said, some tools have been developed, and these tools are called multi-criteria assessment tools because they consider different criteria at the same time. And these tools have been developed to assist decision makers, not just architects, from several scales of the built environment and several levels and from different disciplines in striking a balance, in finding the best compromise when approaching a renovation project. Not just renovation, but they are tools also for new construction in truth. But when applied to renovation in particular, these kind of tools can support designers on two sides. On the first, they can, let's say, provide designers a comprehensive assessment of as-built, because they have a, let's say, structured procedure for the assessment of as-built. And on this basis, the design team can also quite easily set the project's objective before, let's say, starting the design stage. And also, this kind of tool can provide an effective forecast of defects of design strategies on the buildings, and not just on the buildings, as we will see, but also on the on the broader context, so on the, let's say, nearby area. These kind of tools, in my view, are very, let's say, important for architects to be, at least to know, because they really can support the design team in assessing performances of the building through structural methodology, which consists in a procedure for the analysis of different categories, evaluation categories, related with different aspects. So, just to give you some preview, evaluation categories refer, for example, to water, to energy, to sustainability of the site, and so on. And then each evaluation categories usually includes some credits, some, let's say, I would say credits or criteria to evaluate by means of quantitative or qualitative indicators to measure the impact. And among these multi-criteria assessment tools that we have nowadays, I think that the most promising and forward-looking, future, let's say, looking, are those that include sustainability and resilience as guiding principles, for the reason that I said in the opening of this presentation. And the two categories, the two families of these tools that I'm presenting you today are Green Building Rating System, GBRS, and resilience assessment tools. In both cases, their primary aim is basically to certify the level of sustainability or the level of resilience of a building, which is, let's say, the intent, the objective, the scope for which they were developed. But the point is that in my view, they are really, let's say, important, and because they can offer several other benefits for architects, for engineers, for design team in general terms. So not only certifying that a building meets specific environmental requirements or standards, but also acting as a design support tool to analyze and manage complexity, and on this basis selecting more conscious and integrated design actions. Also, these kind of tools are very useful in communicating with the market, with your clients, because very often your clients are not technicians, and so find some difficulties in understanding what is energy efficiency, what is water efficiency, and so on. So these tools use a very informative and very, let's say, simple way of communicating the level of sustainability to the market, usually by means of stars from 1 to 5, or medals with gold or bronze or platinum and so on. And also these tools are very important for the promotion of higher environmental standards, because when applying these tools, the design team is always, let's say, encouraged to reach higher level of sustainability compared to the one that the client is setting as a starting point. These tools basically were developed because we can't really manage what we can measure. This is a quote by an economist, a very famous economist of the 19th century, but the idea, I think, that applies quite well also in our work, in our profession. And so how can we say that a building is sustainable or is resilient if we can't really prove that, if we can really support our claims with numbers, with quantities, with figures, and so on. So how do they work? Basically, you have that building performances, different building performances from different categories, are assessed through a set of criteria or credits. They have different names according to different rating tools that you are using. And each credit is associated with indicators that measure a specific performance. Thermal insulation of the envelope, or number of, let's say, public transport stop nearby the building, and so on. Accordingly, each indicator is assigned a point, one or more point. And then all the points are summed up, and basically you obtain a sort of overall level of sustainability or resilience of a project. Some of these tools work with points, some other, as the DGMB that you can see in the image, works instead with a sort of a more visual, let's say, kind of result of scoring the impact category, the evaluation category, sorry. This is instead the LEED scorecard. So LEED is another of these tools. And here you can see the different evaluation categories that are assessed through this kind of tool. So location and transportation, sustainable sites, water efficiency, energy and atmosphere, materials and resources, indoor environmental quality, innovation, and regional priority that I'm explaining later. So these are basically the main boxes within which you can find specific credits to evaluate, to assess specific performances. And how can you evaluate and assign point to each? You can do that by, let's say, implementing implementing what is included in each credit card. Here you can see one of the credit card for indoor air quality assessment, where you can see the intent of the credit, the requirements, and different options that you have to evaluate the performance that you are that is the object of your study in that case. And then, depending on the performance of your project, of your building, you are assigned 1 or 2 or more points accordingly. Whatever is the system that you are applying, usually the application procedure of these tools is iterative, which means that you continue to repeat the application of the tool until you reach the desired level of sustainability or the target that you have set with your clients. And also these tools are usually encouraging system thinking, since basically the more benefits a design choice, the more aspects a design choice benefit, the higher the project score, and as a consequence, the higher the level of sustainability or resilience of your building is. So the game, the good strategy is to achieve several points in different credits, but using, let's say, implementing just one design strategy. And also these tools are based on the logic of the best compromise. That means that you are not, let's say, required to perform super well in each credit categories. You can perform very well on energy efficiency and not on water management because of the constraint of your existing building, but then you still can get high level of sustainability or resilience. So green building rating system is the first family of tools that I'm introducing you. They have been developed about 30, 40 years ago, 30. And they were developed to measure sustainability. As sustainability was gaining traction as a concept since the late 80s, then we, let's say, we felt the need to also to measure sustainability in a very objective way. So the first of this tool that has been developed was BREEAM, launched in the United Kingdom in 1990, and then very soon the other followed in a very, let's say, limited range of time. These tools are applicable both, let's say, to buildings, but also to neighborhoods. So they are valid for different scales, and also for new construction or different type of renovations. The main evaluation categories of green building rating system are energy efficiency and renewables, water management, conscious use of materials and waste, quality of open space, and user comfort. So you can see that it's not just a matter of energy efficiency, but it's something that deals with very different aspects of sustainability in a building. So the first is BREEAM, which was launched, as I said, in 1990. BREEAM comes from Building Research Establishment Environmental Assessment Method. So you can see, since the name, that are not focused just on energy, but on environmental impacts. It was developed firstly in the United Kingdom, but basically it is well diffused all over the world nowadays. It has several applications from new buildings, interiors, renovations, neighborhoods that can be certified, and it covers different life cycle phases, in the sense that you can certify your building just in the design stage, but also during construction, handover and close out, and also buildings that are already in use. And BREEAM offers schemes to certify both buildings, sites, and neighborhoods, so different scales. And the levels of, let's say, sustainability that you can achieve through BREEAM are these 6: acceptable, pass, good, very good, excellent, outstanding. That, let's say, consists in an association with stars. So outstanding level, the maximum level that you can achieve in BREEAM, is associated with 6 stars, while acceptable is just 1 star. That is, as I mentioned before, a way of communicating to the market of the construction sector the level of sustainability in a very, let's say, easy and easy to grasp way. Then we have LEED, that was the second to be developed in 1998. It was instead developed in the United States, and the name stands, the acronym LEED stands for Leadership in Energy and Environmental Design. Again, we have more or less the same kind of applications on new buildings, interiors, renovation, neighborhoods, the same kind of scales and life cycle phases, even if at the beginning these kind of tools were mainly focused on the design stage and not on the in-use stage. But then the life cycle phases have been expanded more or less in all of these tools. And then we have as levels certified silver, gold, and platinum. Platinum is, again, the maximum level that you can get in LEED. You can get platinum when you score more than 80 points in the criteria that are 51 plus 16 mandatory credits, because the point is that you have a checklist of credits grouped differently in this evaluation category that I mentioned before, and then you can basically choose the credits that suit you the best. So you can choose 1 credit for energy efficiency, 1 credit from water management, and so on. But then, to ensure that a minimum level of sustainability is achieved across all the evaluation categories, you usually also have some mandatory credits that you have to choose for sure. And these are the 16 prerequisites of LEEDs, for example. Then another rating system that has been developed, later, just in 2007 in Germany, is this DGNB that I do not, that I will not pronunciate in Deutsch. And again, we have the same application, life cycle phase and scale, but the peculiarity of DGNB is that they were the first to introduce social quality of the building and economic quality of the project in the evaluation, while the other at the beginning were just focused on environmental impact. And also the other peculiarity is that differently from the others, they used a sort of more graphical and more informative way of returning results. Instead of points, they used that radar diagram. Then in France you have Haute Qualité Environnementale, which was developed from a Paris-based association. And the main market, I think it's just France. It was developed in 2012. And again, it's quite similar to BREEAM in the way of, let's say, assigning levels and assigning also indicators and so on. This is just an image that gives you an overview of the several rating systems that exist all over the world. These are just few, but then there are many others. And so basically, each country has its own green building council that is developing its own green building rating system, which is not that good. But in the end, just a few are really diffusing, are really spreading at international levels, and these are LEED, BREEAM, and DGNB. This is just to say that also in Italy, we have developed, the Green Building Council, Italian, not me, has developed a specific green building, a specific rating tool for historic building rehabilitation. This is the JBC historic building, which is basically a specification of LEED. So it is based on the LEED scheme, and then it adds and it modifies some credits and some evaluation categories. This is implementable only on renovation and not on new construction. And last year, I would say that they also launched the English version, so let's say the diffusion on the international market is starting. And this is just to say that this specific historic building rating system is based on the main category of LEED, but then it adds this category that is historic value. That is a sort of trial attempt to introduce a sort of, let's say, category using a qualitative indicator, because the historic value is something not very easy to let's say, objectivize, to evaluate in an objective manner. Then we have the other family of tools, which is the resilience assessment tools. Because I assume that you have been, let's say, taught about resilience, so I'm not focusing too much on that. But since, I would say, 10 years, it has been diffusing this concept of resilience, which is somehow complementary and somehow contrasting with sustainability. Because it deals with the idea that a resilient infrastructure or a resilient building should keep providing essential services due to its ability of withstanding, adapting, and recovering positively from whatever shocks and stresses it may face now and in the future. While sometimes we tend to think at sustainability as the less is more, or the less is better, maybe. In this case, resilience sometimes works with, let's say, a sort of redundancy of stress very much on durability, on soundness of materials and of buildings themselves. So what kind of shocks? Natural disaster, man-made disaster, and a combination of both. But I assume that you know this concept. The main categories that resilience rating tool evaluate are hazard preparedness, mitigation, and adaptation. I put these in the same line, but actually are different categories because of the different kind of indicators and different kind of strategies that are related with. Materials, durability, and efficiency. And then you see that there is, again, energy efficiency and in the sustainability rating tools, but it's also stressed very much on the production of energy, not just on energy efficiency. And water management and collection. And also, again, users and communities' well-being. These are the main categories of evaluation within actual current rating system for sustainability, for resilience, sorry. Since they are quite new, they are not so many. The most diffused are READY, Resilience-Based Earthquake Design Initiative, which was developed firstly by Arup in 2013 in the United Kingdom, but nowadays is quite well diffused all over the world. The applications in this case is just buildings and not neighborhoods. And the type of disaster that are evaluated, to which the building that is evaluated should respond are earthquake, flood, extreme windstorms. There are different schemes of the rating tools for different type of disasters. And then the levels of resilience that you can achieve through your building are silver, gold, and platinum. Then the other famous resilience assessment tool is RELI, Resilience Action List, which instead is more comprehensive, I would say. It was promoted firstly by Perkins and Will, an American design studio. But now it has moved the run to Institute for Market Transformation to Sustainability. It was developed in 2012. And in this case, instead, you can rely on infrastructures in neighborhoods or in buildings. And in this case, you have, again, earthquake, flood, extreme windstorms, but you have also this idea of resilience applied to a perspective of long-term sustainability. So, coming to the third section, insight for renovation. I've illustrated you these tools very briefly because I really think that even if they were developed for certifying buildings, level of sustainability of buildings, instead nowadays we can really use them for, let's say, providing more effective design and more sustainable and more resilient design with or without achieving the certification itself. So they are a general support in going beyond mere energy assessment in building renovation. They are very useful in considering positive synergies from other issues, not just environmental, not just energetic, but also social and economic aspects. And the idea that the more aspects the project, the design choice that you select, contribute, the better is for the project, is maybe the more important, let's say, contribution of these tools to our work, the more important support that they can give to us. So the idea is that by assessing the as-built performances through these tools, we can then upgrade them, adding what is needed to compensate current gaps in their performances all over the evaluation categories. So I decided to explain you maybe more in detail, more clearly, I don't know, how these kind of tools work by selecting 3 questions that often comes when you approach the renovation project. So one is, for example, how to design effective ventilation strategy in a renovation. This is usually something that is related with the evaluation categories of these tools, that is indoor environmental quality. And on the left, I would say, you can see the list of credits that the Green Building Council historic building version that I showed before as related with with ventilation strategy. So, for example, we have a specific credit that assess the indoor air monitoring. We have another that assess minimum outdoor airflow rate, indoor air quality management plan, both in construction and occupational stage, low emitting materials, counter chemical sources and indoor pollutants, and thermal comfort, both in design and verification stages. From let's say the reading of these credits, within their specific credit cards, we can grasp some very useful design strategy that help us not just to focus on ventilation, but also to benefit on the other aspects of sustainability in this case. So for example, we can see that natural ventilation can be a valuable strategy, not just for improving indoor environmental quality, but also to reduce energy use. But obviously, we can rely on natural ventilation just in some specific cases, because in some other is unpractical and unfeasible, because, for example, just operable windows or doors cannot allow us to reach the necessary air exchange. Then we can grasp that ventilation system, either they are natural, mechanical, or hybrid, can be combined with heat recovery devices that help us to reduce, again, energy demand of the building, but also improve indoor comfort and air quality. And then also it's really important, especially when we deal with historic building, to remember that an adequate ventilation strategy not just is important for people, for occupants of the building, but also for the health of the building itself. Because the building that is affected by mold or decay of components, it's not a building that is, let's say, destined to last. And especially this idea of indoor environmental quality in schools has increased in importance very much during the last 2 or 3 years of pandemic. Since that, up to the point that many of these green building rating systems that have specific schemes to school for certifying sustainability of schools have included several credits to that end. Then another question that it often rise when you approach renovation is how to design sustainable envelopes. So again, in the case of historic building, I selected from the JBC version 1 of historic building the credits that apply: energy system commissioning, optimization of energy performance, renewable energy, and advanced commissioning. From this, I grasped some, let's say, strategies, overall strategies that you can see on the slide. So, for example, even if reaching energy efficiency in historic building can be very challenging and very difficult, the point is that we should, let's say, think the other way around, change our perspective, and think that it is not just a matter of increasing the energy efficiency of the building, but it's also a matter of protecting the building itself. So in this sense, if we change our perspective, probably energy efficiency strategy in historic building rehabilitation can be implemented more easily. So improving as much as it is possible, the energy efficiency of the building, and as much as it is in line with the usage patterns and of different users. And then, when possible, when you approach the design of a sustainable envelope, you can implement innovative design concepts related with the integration of renewables on the facade. And also you can install or upgrade shading systems that minimize the use of energy to run themselves. So again, to find the synergy with other evaluation categories of the green building rating system. So shading systems that, for example, are passively activated, that do not use energy to operate, to rotate, to open, and so on. And that somehow are capable of self-adapting to climate to climate condition, to solar rays, and so on. And then the last question that I tried to answer is how to use materials effectively. Again, I illustrate the list of credits from JBCHP version 1 that are related with materials and resources. So we have building reuse that allow to retain existing technical elements and finishes. We have management of demolition and construction waste. We have reuse materials, environmental optimization of products, materials extracted, processed, and produced within a limited distance. So, for example, reusing materials on site as much as possible in a renovation project can be performed if you have some, let's say, tools to evaluate the residual performances of materials, functional performances, residual value in terms of also of aesthetic and technical value of that material or that component. And in this way, reusing materials on site or reusing materials from our construction, you can contribute to save tons of new materials and resources to be used, and so also minimize the generation of new waste for the construction sector. Another strategy that you can implement is to contribute to circular economy processes by take the materials that you can't use in that site and insert them into a circular economy process. So dismantling components and materials are usable or recyclable elsewhere. And also you can use new materials, obviously, with low environmental impact along the whole life cycle, their whole life cycle span. But again, not just focusing on that, but also paying high attention to the compatibility of old and new materials. Especially in historic building, you might know that it's always, let's say, tricky to introduce materials which do not allow the humidity to move from the wall outside. And this is just a picture from a European project, an Interreg, about different ways of reusing materials within the same renovation project, or to, let's say, move them towards circular processes related or not with the construction sector. So, final section. I've illustrated you these tools, so these green building rating system and rating assessment tools, in general terms, obviously. Let's say that these tools for me are really important because they offer designers, architects, a structural way of approaching the design. And also very important because they are, let's say, open and in continuous development. So they follow the new, let's say, need of the construction sector itself. And for this reason, when I was doing my PhD, I decided to, let's say, make an attempt to enhance one of these tools. And using it for supporting designers, supporting architects in designing new factories or renovating existing factories in a sustainable way, in a way that was, let's say, environmentally sustainable, but also compatible with the landscape, integrated with the landscape. Because as you have seen, some of these tools, and it's a case of DGMB, has introduced different categories of sustainability which are not specifically related with environment. So they have introduced, as I said, social sustainability and economic sustainability. So I decided to make a trial and integrated lead to evaluate the sustainability of factories, assuming this more broad perspective of sustainability, including also, let's say, visual aspects, which is not obviously this. This is not a sustainable factory, this is just greenwashing. So since these tools are open to change, I make this proposal for integrating LEED version building design construction with new specific indicators to measure the perceptual aesthetic interferences of manufacturing of factories, green factories. And in this way, exploiting positive synergies among environmental and visual aesthetic aspects in factory design. So basically, I tried to add a new impact category beyond the ones that you have already seen in LEED. I added the perceptual aesthetic aspect, that is the last one. And I developed 8 new credit, evaluation credit that were meant to assess how much a building, a factory was, let's say, sympathetic, was integrated with the surrounding, with the scene. So these are just 3 of them. One of the credit is morphological harmonization of the building, one other is chromatic harmonization, and then I also have site receptiveness and attractiveness. And for each of these, I developed also, I filled a credit card where, again, you can find the intent of the credit, the requirements, and let's say the procedure to evaluate the impacts and assign a point. And then also I associated with this credit evaluation a series of mitigation practices specific for that kind of impact that was assessed. Yeah. So the result of my PhD thesis was basically this. That is a modified scheme that includes compatibility with the landscape within the sustainability assessment of industrial sites. In total, I had 10 evaluation categories, 62 credits, which include the 8 that I had, and over 300 good design practices that are associated with these credits. Obviously, these tools have also some limits. They are not just gold. Some of the limits that can be, let's say, explained are related with regional application. As you have seen from the map with different rating system, there are plenty of them. So each one is basically speaking its own language, which is not good for comparing sustainability across the world. This has a reason, obviously, because sustainability sometimes is site-specific, needs some site specification, let's say. But obviously, these introduce some difficulties in this field. And so as a result, we have sometimes some difficulties in comparing metrics and also achievements of sustainability and resilience across the world. And to, let's say, fill this gap, to overcome this problem, some of the promoting institution of green building rating system have introduced the regional priority credits, which is the case of LEED, for example. That LEED has introduced this category, evaluation category, that has equal importance to the others, where you can give, let's say, point to specific design practices in the project that are related with necessity of a place. If a place, for example, is highly dependent on water collection, so in that specific place, LEED will let's say, reward particularly projects that are working with that. But the whole structure of the rating is the same all over the world. Just change this, let's say, piece of the puzzle. Some other have agreed some common metrics, and it's the case, for example, of the European framework levels, which has been released 2 or 3 years ago, and now it has been released in a new version. So the European Commission decided to, let's say, develop some common indicators for sustainability in buildings, and some of these tools have included these metrics within their evaluation credits. And also some guidelines have been developed to harmonize at least the structure, the overall structures of these tools. Another possible limit is that it has been, let's say, addicted to have a limited perspective, in the sense that it has often been criticized, this family of tools, to be focused just on environment, overlooking instead social and economic aspects of resilience and sustainability. But as I said, one of them has already, let's say, tried to fill the gap, and it's DGMB. So DGMB has introduced a brand new category for evaluating these different aspects, while some other that were, let's say, more shy, have just introduced new credits, single credits for evaluating social aspects or economic aspects. Some others have chosen to behave completely different and change the perspective from being oriented on the building to user-oriented perspective. So, for example, you can find the rating system well and the rating system fit well that are evaluating sustainability of buildings, but through the evaluation of user satisfactions, user well-being, user comfort, and so on. Another limit that can be, let's say, found for these tools is the accessibility, because maybe I didn't mention that these tools are voluntary. The application of these tools is on a voluntary basis. So the government can't put them mandatory. So they are voluntary, and so they are criticized to be sometimes for few rich people, rich investors, rich clients, because of their registration fees. If you want to certify your building, you have to pay a fee, but that's not the most important, let's say, cost voice, because then you have that the most important share of cost of these tools is related with the salary of the professionist, the practitioner, that is preparing documentation for the certification. Because you have seen that, for example, LEED has more than 60 credits. Assuming that you are not choosing all, you are choosing just 50. You have to pay someone, if it is not in your design studio, to fill the form, measure all the performances, and so on. So it is true that maybe sometimes these tools are just for each, but it is true if you want to achieve a certification. But for me, what is most important in this kind of tools is that you can also find some let's say, short guide, free, open for all on the website of this promoting institution, and this can support you in designing buildings in a more sustainable way without, let's say, achieving the certification. But also it's true that in the long term, the cost of, let's say, practitioner that prepared the certification is counterbalanced, is paid back from, let's say, the better performance of the building and also the shorter construction times because of the better management of the construction process itself. Why going for a building certification? From the perspective of a client, of an owner, of an investor, basically to effectively communicate to the market that your building, the building that you are launching on the market, putting on the market is sustainable, is resilient, has an added value, I would say. There is some studies from the lead, let's say, the committee that say that the value of the property increases of at least 2%. And so this can be, let's say, an economic leverage. But then also to offer users a better living environment. And this is particularly important in, for example, offices, renovation or new construction for offices, where a better living workplace usually, let's say, correspond also to a higher productivity of employee. It is in fact estimated that in green buildings, usually you have 27% more satisfaction, level of satisfaction in the occupants. And then also to save money, not maybe in the short term, because construction costs of green building and resilient buildings sometimes are higher, but then in the medium to long term, it is estimated that you can reduce the 30 to 40% of energy and water consumption compared to similar buildings. And this was the perspective of the clients, but then what interests me the most is what are the benefits for us, for architects. As I said, I think that these are very valuable tools, flexible in the application, and can really guide you to reach this best compromise in your projects. And the means that these tools offer to you is for sure integrative approach, integrative process and system thinking. So this idea of contributing to several aspects by the same design choice. And then they offer you for sure a structured design process and useful toolkit also for the evaluation of specific, let's say, effects of your design strategies, of your design choices. And again, it's an easy way to communicate with clients and other stakeholders of the built environment. And also it's a way of distinguish maybe from other practitioners and provide climate-proof and user-centered buildings for now and for the future. I think that I concluded too early, but just to conclude with this quote by the president of the American Institute for Architects in 2018, Carl Elefante. The greenest building is one that is already built. But again, this is not enough, not just renovating the buildings, the built stock in a conventional way. Today we are all called to renovate the stock in a sustainable or resilient way. Thank you.
Thank you, Dr. Marchi. Maybe we can take some questions. Yes, Chloe.
Yes. J'ai besoin de me présenter. Okay. So Chloe Lenormand, I'm a PhD student in the school. No, it's okay in English. Thank you. Yes, you mentioned that. So you mentioned the use of these labels as a tool for designing. I have a question about the paradox that we meet sometimes. So the cost, as you said, of these labels, of getting the end grade and the number of the label is high, and it's, as we sometimes observe, it's not very useful having just a number at the end. What's important, as you described it, is running after this label because it makes your project better in the end. Paradoxically, sometimes there is no budget for going after a label. People do the project and end up, after an assessment, with an even better grade than if they had run for the label and did the process in a more organized way. How would you explain achieving objectives in this way, and how would you recommend that we could do according to the different substances of the project?
Okay, so thank you for the question. For what concern, let's say, the achievement of the certification, it often happens that if you intend to achieve a certification, you are, let's say, driven to chase points in some way, at a point that there is also a name for this approach that is lead brain, in the sense that design teams, when they want to achieve the certification, or rather the clients, because it's the clients that support this, want to achieve the higher level with the minimum effort, let's say.
Some students do that. They just want the grade. They don't want to understand.
With the less effort. And so, it can happen that sometimes just using this kind of tools without really without having the intention to achieve a certification for the market, can result in a better project, because you're not focused on gaining points, but just focused on following the structure of the assessment and and implementing the best strategies that you can, also to save, let's say, resources, both tangible and intangible, but with the same design choice contributing to several aspects, so several issues. So it can happen, basically, that instead, when you approach the certification because you want to gain a lead platinum, you just focus on points, easy point to get, easy point to grasp. Not sure if I reply, more or less.
Okay, so I have a question. Is there any situations, and by that I mean like any countries, where all these tools can become legislation in a way, as for building purposes?
So in Europe, as far as I know, that's not possible, because they are tools that are market driven, and they are, let's say, developed by private institutions. But what I can say is that, for example, in the United States, they can somehow refer in a public competition for design. They can mention the achievement of at least a lead platinum or a lead silver, and so on. I'm not sure if it is, let's say, legal or not, because actually I also know that there were some legal action going on in the last years for this reason, because it's not so easy to superimpose a system that you have to pay for achieving a sort of level. But yeah, for sure, we can't in Europe. You can instead, as a private company, launching a competition for design and for construction and design. You can require that the participants prove to have achieved at least a certain level in whatever green building rating system you want. Yeah.
You can also do that with public markets.
In France? Okay. In Italy, I'm sure that is not possible. To
I know, for example, that the Metropole, for some buildings of the neighborhood, they ask the promoters to implement like 24 or 18 kilograms of bio-based material for each square meter.
okay.
And that comes from a label of bio-based.
Okay. But it
Take the whole label, but
okay, just some part.
I believe that it would have been illegal for them to ask for that condition.
Okay.
First of all, I would like to thank you for the presentation. I have a question concerning the life cycle assessment. I am not sure if you have already mentioned it within the design and support tools, but can we consider it as the most effective design and support tool, since it concerns all the life stages of a building? And I think it has that cost optimization aspect in it. And is it? I was wondering also if it is applicable worldwide and in all the renovation projects.
Okay, so thanks. Well, actually, life cycle assessment tools are different tools from this, in the sense that it is true that I mentioned life cycle, but life cycle assessment are procedure with, let's say, a very analytical way of measuring the impacts and so on. That is right the reason because these kind of tools were developed to, let's say, make the measurement of sustainability easier somehow. Within this kind of building, with kind of rating system, you can have some reference to life cycle assessment, but just in the sense that you can have, for example, credits that evaluate the impact, low impact of materials. And so in the calculation of that credit, you can refer to life cycle assessment strategies, or you can also have an option to, let's say, measure that performance of that material that you are using just by providing its environmental product declaration and demonstrating that it is within the range that the rating is offering you. Another kind of credit, for example, in LEED, because it's the one that I know the most, is related with the recyclability of materials. So again, in that credit, you can find some options to calculate the credit, to calculate the impact, that are based on a life cycle assessment tool, or another option that just ask you to calculate the percentage of material that your component is composed of, that comes from recycling process, and so on. So the idea in general terms is that we should let's say, make the sustainability measurement easier, not instead more difficult. It is also true, on the other hand, that life cycle assessment is the most, let's say, analytical and scientifically robust methodology that we have to consider all the impact. But it's quite time-consuming and not just time.
Question, because it's not really reliable either. It's supposed to be scientifically based, but one can check every day when you look at the results for different that different companies present for their products, similar projects, that they're not so reliable. So if life cycle assessment is not that reliable, how reliable are these other indicators which are not so, how do you say, easy to compute? But I had another question, if you allow me. It seems, because I'm not familiar with these tools, that they're kind of checklists.
Mm-hmm.
And I think it seems difficult to use them when you're in the design process. When you're starting from scratch, you want to know how things work rather than have checklists. For example, if you want to have natural lighting, then that is in conflict with the fact to have a compact building. And how does this conflict emerge in a checklist? It's just an example to show that the way you presented it, I didn't understand how it was a tool for design,
Mm-hmm.
a tool for assessment. That's quite clear, but maybe you could.
Yeah. First of all, a sort of premise that maybe I didn't do before, that basically they are just for assessment. It's me that I'm asserting that they are for design support. But because in my view, basically it's the whole process behind the achievement of a certification that encourage this idea of designing effectively according to all the aspects. Because, for example, when you start the design, the pre-design phase of this, when implementing the certification, you have to demonstrate that you have performed at least one or two design charrettes. Is it correct? Charrette. It's like workshop. I thought it was French, but maybe it's just charrette. It's like intensive workshop according to the
Very
late concept.
intensive.
Okay.
Well, it's charrette in France is when you're late, when you have to when you're very late. You're
Okay,
charrette.
so it's
I don't think that's
maybe
what you mean.
an American word. That stands for intensive workshops with the clients, with the other, let's say, the design team, all the part of the components of the design team, and also with other stakeholders. So you have to perform this intensive workshop where you set goals of the certification and so on. And in that let's say event, you can basically choose the credits that interest you the most, and then you can check if these are conflicting or not by looking into the last part of the credit card, where you can see correlated credits. Because maybe I didn't, I just shown you these. I just shown you the first part of the let's say, info sheet for one credit, but then usually there are at least 3 or 4 pages where beyond the intent, the requirements, and the regulation reference and so on, you also have the correlated credits. So there you can see, for example, in this case, you can have indoor air quality assessment and then correlated credit energy demand of the building. And so in that, you can see that there are direct correlation between what we are performing in indoor air quality assessment and the other credit that is correlated. Then yes, it's not so direct, so easy, but it's a first view that you can have of the synergies and positive or negative synergies among different aspects. So.
Okay, so maybe we can try to do that with our students to oblige them to, in the beginning of the project, to set themselves goals and to try to see how these conflicts between each other. It's like this would be some kind of project methodology to have that intensive.
Yeah, I've never tried actually, to be honest, but in my view, it could be the good choice.
Any other questions? If not, I have one. Sometimes, not only once, there's a criteria here that's called innovation. Why would that have anything to do with sustainability?
It's usually these evaluation categories award, reward, let's say, projects that demonstrate to go beyond the business as usual techniques, strategies, and certain sectors. So, for example, if you achieve 50%, no, sorry, 200% improvement in energy efficiency, just to say a number, compared to the legal requirement. So basically you can get 1 or 2 points in innovation. Usually there are few points that you can get in this because the threshold is already high. The starting point of this, let's say, of the performances that are assessed is already high. So this is one, just one example.
I understand it's not innovation for innovation. It's because you go beyond.
Yeah.
Okay.
No,
Any
and
other
also
questions?
just to conclude. Yeah. No, just an additional information. That is that sometimes in innovation lead, at least, I don't know the others, rewards you if you, let's say, demonstrate to achieve a specific performance, which is already evaluated through the other one of the other credits, but you, let's say, achieve that in a way that is new and that cannot be, let's say, measured by indicators, because indicators are not already, let's say, available for that specific point, the specific measure. But if you demonstrate to have achieved that by means of on-site measurement and on-site assessment when the building has already been built. Sorry.
Thanks, Leah. You mentioned that in your test you suggest to add criteria about the adaptation of the morphological building to site. Did you suggest to propose how we can evaluate these criteria and or maybe measurement?
Yeah, it was something that we were discussing shortly at lunch. My PhD thesis was a little bit an experimentation, let's say, because I was allowed to. But the fact that Green Building Council Italia has already included an evaluation category on historic value evaluation is, let's say, a proof that somehow we can effectively implement also qualitative indicators in the assessment of sustainability. But yeah, to come to that specific credit, I proposed in credit info sheet different options to evaluate the morphological harmonization of the building with the surrounding. One of that option was related with let's say measuring the different typical dimensions of the built environment. So, for example, height and length and the base of the buildings surrounding, and then comparing them with the one of the new building that we were evaluating, and so to see if there was too much difference. Probably it's not just an indicator by itself, but let's say this was an option to encourage the designer to reflect on that point. Another one was based on a viewshed analysis, was based on a GIS system, so the computer-based information system that was modeling the ground and was evaluating the portion of the view that were, let's say, obstructed by the building, and not the visual channels that were obstructed from the buildings or not, and so on. So this was a more objective option, maybe, to evaluate the credit. But then also I'm well aware that the effect of assigning points to these credits was quite, let's say, subjective. It was exposed to the judgment of an expert. That was why I let's say, required in the introduction of my, let's say, evaluation additional evaluation category, that the evaluation would have been performed by a professional, practitioner with, let's say, experience in landscape evaluation and so on, landscape impact evaluation, so on. But yeah, it's true that we can have, let's say, a certain degree of differences in point assigned by one and by another expert.
Thanks.
Any other questions? If you're not familiar with English, you can ask your question in French, and Walter Balducci will translate in Italian. No? Okay, well, thank you for listening. Thank you, Dr. Lia. It was a pleasure.
Thank you for you.
It was very
for
instructive,
your
and
presence.
I hope we can still have time to discuss later on. Merci encore.
Thank you.